So hello everybody, my name is Susanne Brix Petersen and I'm an associate professor at the Technical University of Denmark. I'm sorry if these are a bit small. The Technical University of Denmark is also abbreviated DTU, standing for Danish Technical University, and you see here that we have Copenhagen here, and DTU is located just a bit up north in the Copenhagen area, where we have a lot of green space, so it's actually quite a nice place to stay at a daily life, you could say, or working life. The Technical University of Denmark is divided into a little bit more than 20 different departments, where I'm part of a new department that was generated only 2 months back, called DTU Bioengineering. My work there is mainly focused on immunology, and I have a group there called Disease Systems Immunology, and I'll talk a bit about what we are doing in this group here today. So, first of all, our research focus is centered on lifestyle-associated diseases and to identify different key factors that are leading to immunoregulatory events in these diseases. We also, of course, want to use this information that we generate in order to identify and design novel strategies to combat these diseases. But of course, that's the long-term perspective. So in many of these lifestyle diseases, you have low-grade systemic inflammation, as you will know here as medical doctors, that are part of these lifestyle-associated diseases. But actually, we don't know where this is coming from. And one of our main focus areas is that we want to identify where we have them from. And some of these components that we are exposed to in our daily life is from our microbiome, the gut microbiome, for example, or the gut bacteria or gut viruses and whatever we have in our intestinal tract. And as you will know, I guess, most of these components that are part of these microorganisms, they can initiate an inflammatory cascade. But at the present stage, we don't know how they do it and how they interact with our host during these different diseases, and this is part of what we have a great focus on. We also look, as I said before, on the environment, both of the mother but also of the infant, and trying to identify factors that are involved in programming of diseases, both in early infancy but also in later life. And having a great focus on the interaction here with the microbes and the immune cells or the host cell compartment. We have also recently moved into the metabolic field together with collaborations with Carsten Christiansen, where we also look at adults with metabolic disorders. So just to give you a few clues on how we work, we have a specific, as I said, interest in immune cells and their interactions in lifestyle-associated diseases. So having very much focus on different types of immune cells, because many researchers have a specific pet immune cell that they study, and they actually don't know a lot about the networks of interactions between our different cell types in the body, the tissue cells, but also the immune cells. So we try to actually get a network of interactions between these immune cells and try to understand all the different types of cells and how they interact in the system. This is not easy, and therefore it's a long-term perspective to generate this knowledge. And we have a specific focus on early life diseases like allergy and asthma, which we have at high prevalences in the Nordic countries in Europe, and also on obesity-related disorders, which is a main problem in the world today. And as I said, we also have focus on nutrition and also on how the different dietary factors are shaping the microorganisms in our gut, and how this is then interacting with the host and immune reactions that are initiated. And here in this part of our research areas, we also look into all the genes that are part of our microorganisms in the gut, what they can actually produce of different factors that can then activate our immune system. So we try to use all the genomic information that we have within our gut microbiome in order to kind of come up with some hypothesis of what could be that are driving these types of diseases. So this is purely, you could say, a prediction-based tool, but then we can actually use it to maybe bring up some hypotheses that can then later on be tested in human settings. Okay, just to give you a very brief view on the methodologies we use, we sample quite a lot of different samples, mucosal fluid taken from the nasal cavity of these infants. Also, of course, blood and tissue, specifically tissue in terms of animal models, where we can pick out whatever we want if we have first sacrificed these animals. We look into the fecal matters, for example, for sorting of these IgA-coded bacteria. We also have the capacity to sort single cells, also very rare immune cells, for example, that we sort by the technology of FACT, flow-assisted cell sorting. And then in many of these studies where we look at the pathogenic interaction with immune cells and how it can kind of trigger us, then we do a lot of different functional studies in vivo. Many of these studies here we use different types of omics-based methodologies and try to integrate all the different analysis or data we get by using bioinformatics, thereby somehow to try to interfere how that is related to the type of disease, infants or adults. We use flow cytometry a lot, and we also use a specific technology for high precision immunoassays, meaning that we can actually identify to very low levels the presence of specifically immunological biomarkers, but also, of course, insulin and whatever is interesting in these different types of foods that we use. We have specific interest in different factors, environmental factors regulating the immune function in early life, and also in gut genomic profiles and allergy in infants early life. We look at the diet microbiome, immune axis in metabolic diseases, and then we also have specific projects where we look at circulating biomarkers and autoantibodies in lifestyle-associated disease. I think I've used my time now, so I'm going to stop here. But thank you for listening.